Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here is a problem from IMO Longlists. If I remember it correctly, it should be 1970, probably P7, something like that. Okay, let A, B, C, D be an arbitrary quadrilateral. It's an arbitrary quadrilateral. Squares with M1, M2, M3, M4 are constructed on AB, BC, CD, DA respectively, all outwards or all inwards. Prove that M1, M3 equals to M2, M4 and M1, M3 is perpendicular to M2, M4. So let's draw the figure first. Right, and we want to construct squares. So A, B, C, D here. So this is our figure. So let's give them names A, B, C, D, E, F, G, H, I, J, K, L. Right, and we have the center would be M1, this center would be M2, this center would be M3, and this center would be M4. We want to prove that M1, M3 equals to and perpendicular with M2, M4. We want to prove this. So for this problem, if we look at the figure, it's close to table theorem, which is it's about three theorems called table theorem, and the last one is extremely difficult. We will talk about that later, but let's look at this one. This one, so the figure is quite close to the first theorem of the table theorem, but it's a little bit more difficult because in the table theorem, A, B, C, D should be a parallelogram, and here it's an arbitrarily quadrilateral. Now, if we think about this problem, the idea is that the only useful information here, right? The only useful information here is that we have four squares. That's the only useful information, which means we have to find the relation between these four squares, right? So for the fourth square, we have the knowledge that the four sides are equal, right? That means AD, DK, LK, AL are equal, and DC, CI, IJ, DJ are equal, right? And other property we have is that M1, M2, M3, M4 are the center of the squares, which means M1 is a center or is a midpoint of segment AF, right? And M3 is a midpoint of segment DI and CJ, right? M1 also the midpoint of segment EB. These are the information we have. So based on this, we know that we want to prove M1, M3 equals to M2, M4. So basically, if you look at this figure, you have the feeling that maybe we have to construct two triangles, let them to be congruent, and therefore we can prove M1, M3 equals to M2, M4. And a good sign here is that M1 is a midpoint, and we know that M3 is a midpoint, which remind us if we can find a midpoint to form two triangles, then the problem might be solved, right? So in this problem, let's connect AC here, and we find the midpoint of AC here, right? Let's call this point as T. So now we connect M1 T and connect M3 T. Now we have much more information, right? Because if we look at M3T, M3 is a midpoint of CJ, T is a midpoint of AC, which means M3T is in parallel and equals to half of AJ. Right, now we connect M4T and M3T, sorry, M2T. If we look at M4 is a midpoint of AK and T is a midpoint of AC, which means M4T is in parallel and equals to half of KC. So what's the relationship between AJ and KC? Then the problem is obvious because we know that angle ADJ equals to angle KDC, right? Because angle KDC is 90 degrees plus angle KDJ, and angle ADJ is 90 degrees plus angle KDJ. So we know that angle ADJ equals to angle KDC, and we also know that AD equals to KD, JD equals to DC, which means triangle ADJ is congruent to triangle KDC, which means KC equals to AJ. Therefore, we get M3T equals to M4T. Right? And also we know that KD is perpendicular to AD and DJ is perpendicular to DC. So, and also these two triangles are congruent. That means AJ is perpendicular to KC. So we also know that AJ is perpendicular to KC, which means because M40 is in parallel with KC and M3T is in parallel with AJ, so we know that M3T is perpendicular to M4T. Right, we get this one. And similarly, we can prove that M1T equals to M2T. And M1T is perpendicular to M2T. Then we know that this is 90 degrees, this is 90 degrees, so the angle M4T M2 equals to angle M1T M3, which means triangle M1T M3 is congruent to triangle M2T M4, which means M1 M3 equals to M2 M4. And also because each side of these two congruent triangles are perpendicular, that means M3 M1 is perpendicular to M4 M2. Right. So the key point of this problem is to think of the problem set we have. It's very limited, right? Just the squares. And from the squares, the only thing, especially look at M1, M2, M3, M4, the only thing we can get is a midpoint. So we have to use it. Right? Once you think about the midpoint, how can we use a midpoint to put it into a triangle? That's the only way here. Then the problem becomes more clear. Okay? I hope you like this video. See you in next one. Thank you.